Responsibility. I'm the Toxics Program Manager here at PSR, and I wanted to thank everyone for joining us today for our webinar on eating for climate and health. And I wanted to just give folks maybe another minute or two to jump on, and then we will get started. Okay, thanks again. Okay, why don't we get started? We have a good group of folks on the line already, and so once again, this is Kathy Attar with Physicians for Social Responsibility. I'm the Toxics Program Manager here at PSR, and I'm going to be introducing today's presenter, Dr. Michael Martin, who will be talking about how climate change harms our food production system and also has harmful impacts on our food. And in particular, he's going to be looking at different food-raising practices that are detrimental to our climate. And so I'm going to be introducing Dr. Martin, and then he's going to be giving his presentation, and then we will be taking questions at the end of the talk. And you can type those questions into the question box that's located on the GoToWebinar control panel. And so let me just tell you a little bit about Dr. Martin. He is an associate clinical professor at UCSF Department of Epidemiology and Biostatistics. He also sees patients at the Zuckerberg San Francisco General Hospital, and he is an active member of our Bay Area Physicians for Social Responsibility chapter. So Dr. Martin, let me turn it over to you. And once again, we're going to be holding questions to the end, and you can, if you do have a question, feel free to type it into the question box, and we're going to get to those at the end of the presentation. So here you go, Dr. Martin. Thank you.
Thanks for the, the introduction, and thank you everyone for joining us today for this webinar. I'm delighted to share with you information on the two-way relationship between the food we eat and climate change. I say two-way because the food we eat dramatically impacts climate change, and because climate change poses a massive challenge to our food production system. That two-way relationship between the food we eat and climate change is a key takeaway from this presentation. I also want to talk about steps you can take right away to make our planet healthier and our future more secure. Our actions today and in the future can make a major impact on our world and on climate change. Next slide.
Yeah, sorry, my computer is frozen. Hold on a second.
Okay, very good.
Sorry about that.
No problem. Most people don't know it, but we've made remarkable progress in reducing hunger and poverty in the world in recent years. Since 1990, the number of people living in extreme poverty has been cut in half from about 1.9 billion people to about 750 million. That's something we should all be very proud of as healthcare providers and as health policy specialists. However, climate change is going to be a problem for that, and it's estimated that by the year 2050, 10 to 20% more people globally will be at risk of hunger. If climate change's impacts that are possible come about, it's possible that there could be literally hundreds of millions of people who are facing starvation in the years ahead. Next slide. You leave it on this one. This is fine. As I mentioned, there's a two-way relationship between climate change and the food we eat. Let's first talk about how climate change harms our food production. Well, let's begin by talking about the three ways that climate change harms food production. These ways are its impact on higher temperatures on crops, its impact of higher temperatures on water availability, and its impact of higher temperatures on extreme weather events. First, the impact of higher global temperatures on crops. Higher global temperatures, they induce heat stress. This limits plants' metabolism, their growth, and their development. Higher global temperatures dry soils. This leads to more evaporation from soil and drier soil that doesn't absorb water easily. Higher global temperatures decrease plant immune response. This leaves plants less able to fight disease. Higher global temperatures promotes weeds and pests and fungi. Many weeds and pests and fungi thrive when there are higher temperatures and when there's more CO2 in the environment or in the atmosphere. Higher global temperatures also reduces crop yields, and although some crops grow faster in higher temperatures, yields are often reduced. For instance, rapid growth of wheat can lead to bigger plants but smaller seeds and ultimately lower yields. Next slide. Higher global temperatures also have an impact on animals. For agricultural animals, high temperatures result in heat exhaustion, decreased immune response, decreased food intake or feed intake, and decreased production of milk, meats, and eggs. For pollinators, high temperatures result in heat exhaustion, dramatic decreased immune response, and particularly for them, reduced availability of pollen, which is their food, and an increased incidence of pests and pathogens. Next slide. Now let's look at the impact of climate change on water availability. Climate change has reduced the water for food production, and it's done this in a variety of ways, through droughts, through groundwater depletion, and through uneven distribution of rainfall. About 80%, that's 80% of agriculture depends on rainfall for water. Climate change causes very uneven distribution of rainfall, with more arid conditions in some places and wetter, more humid conditions in others. This has a dramatic impact on crop growth and on agricultural productivity. Next slide. It's very clear that extreme weather events damage agriculture. Water is generally a good thing for plants, but intense downpours and floods are not. Extreme weather can lead to crop loss from flooding caused by severe storms, waterlogged soils, soil erosion, soil contamination, and we also have the problem of storm surges and rising sea levels. This causes contamination of soils and aquifers through salinization. We've all seen dramatic news reports showing fields in the Midwest and South that have been flooded by torrential downpours. This picture kind of brings that to mind. Crops don't, fields and crops don't do well when there's standing water, and animals suffer as well. I don't know if anyone's on the call has noticed, but there's been recently a dramatic increase in the lettuce price around the country, and that was due to the very heavy rains in California, which has led to later planting and inability to plant lettuce for many farmers who are the primary lettuce growers for the nation. Next slide. Now let's look at how climate change not only affects our food production, but how also it harms our health. One of the ways it does is through heat-related illnesses. Exposure to extreme heat can cause, cramping, heat exhaustion, even heat stroke. And heat stroke can lead to a variety of conditions: delirium, convulsions, coma, eventually even death. Children and older adults and those with pre-existing conditions are the ones who are particularly at risk. So are people who live in in urban settings without air conditioners. Chronic exposure to extreme heat can lead to high levels of anxiety and stress, and it can negatively impact mental functioning. And we can only imagine the stress put on people around the world in areas such as India, where temperatures can reach over 100 or 120 degrees even in some places. Next slide. Climate change also harms our health through waterborne diseases. These diseases include hepatitis, Legionella, giardiasis, and cholera. Runoff and floodwater can contaminate drinking water with bacteria, viruses, and protozoa, and that can lead to outbreaks of waterborne diseases, such as those ones I mentioned: the hepatitis, Legionella, giardiasis, cholera. In rural areas, water runoff picks up animal waste and pesticides and fertilizers. In cities, runoff carries pollution with it and can overwhelm the sewage system, causing untreated sewage to flow into drinking water air systems and recreational water sources. If you look at this picture here in this slide, one can only imagine the pollution that it had caused, the pollutants that were in the water, and the bacterial contamination that occurred in the areas that are here flooded, and when the floodwaters recede, how much toxic material and disease-prone situations there would be in that area. Next slide. Climate change also harms our health through vector-borne diseases. These vectors are carriers that transmit infectious diseases between humans or from animals to humans. Vectors include mosquitoes, the ticks, the fleas, as well as birds, rodents, and snails. The mosquito is one of the most common vectors, and it carries a variety of illnesses, including malaria, dengue fever, West Nile virus, and other diseases. On a somewhat personal note for all of us, we can look to the future for more mosquito bites in the years ahead. Unfortunately for us, higher temperatures lengthen the breeding season for mosquitoes, and they boost their reproductive rates. They even increase their biting activity. So that's going to be one of the unfortunate things of climate change for us personally. Next slide. Climate change also harms our health through increases in ground level ozone. Higher temperatures increase the formation of ozone, and ozone has many, many harmful effects. It has widespread and dangerous effects, including damaging lung tissue, provokes new cases of asthma, makes existing asthma cases worse, and increases the risk of heart disease and exacerbates existing heart disease. Ozone is also a very significant and powerful greenhouse gas. I don't know if everyone knows this, but ozone is not something that is primarily produced out of tailpipes or coming from factories. It's produced in the atmosphere through a combination of chemicals, the nitrous oxides and the volatile organic compounds that are spewed out by power plants and other facilities. And when they are in the atmosphere together, it's the sunlight and the heat that together cause them to form ozone. And so the higher the temperature, the more that reaction occurs and the more ozone there is. So with climate change and global warming, we can expect more problems with ozone and higher ozone levels. These nitrous oxides and volatile organic compounds that combine to form ozone are generally emissions from industrial facilities, electric utilities. They come out of the exhaust of our cars and come from chemical plants and chemical vapors. Even gasoline, if it's spilled and creates vapors, can create these volatile organic compounds. Next slide. We've been looking at how climate change affects our food system and our health. The flip side is the way we produce our food also damages the climate. So it goes both ways. Next slide. Now this slide is a little complex, but basically it provides information on the carbon footprint of our food. It gives the total life cycle greenhouse gas emissions for various household foods. And you can see there are 8 bars on this graph, and each of these bars represents a different food group: red meats, other miscellaneous oils, sweets, condiments, fruits, vegetables, dairy products, chicken, fish, eggs, cereal, carb, and beverages. The length of the bar tells how many greenhouse gas equivalents are produced by that category per household per year. So you can see that the 2 most carbon intensive categories here are red meat and dairy, far ahead of all the others in terms of the length of these bars and greenhouse gases equivalents produced. You can see that for red meat there's 2.4 tons of greenhouse gas emissions per household per year, and for dairy it's 1.4. Others are much, much lower, with oils, sweets, and condiments being less than 0.5, a dramatic difference. So those 2 categories, the red meats and the dairy products, are the ones we really need to look at as potential being problematic for greenhouse gas production. So this slide shows how many greenhouse gases are produced by red meat. Now let's drill down a little bit. Next slide. Let's drill down on how livestock production damages the climate. This is an pretty astounding statistic. Livestock production Livestock production accounts for 18% of all greenhouse gases. Tremendous amount. I believe it's more than motor vehicles. That's an astounding statistic. And the big problem here is methane, which is 39% of agriculture's greenhouse gas emissions. Methane is extremely powerful greenhouse gas. It's not simply as bad as CO2. It's 86 times more powerful than CO2 in terms of heat trapping ability and greenhouse gas equivalents. Although methane decays in the atmosphere more rapidly than CO2, it has a half-life of about 12 years. So although it decays more rapidly than CO2, it decays into other gases as well, including CO2. And those other gases linger in the atmosphere for an extended period of time. So it's a hugely problematic result of livestock production. Next slide. Okay, cattle and sheep generate methane, and they do this by belching it out and farting it out. There's some debate about how much methane each cow produces, but the United Kingdom's Greenhouse Gas Inventory Report noted that dairy cows release approximately 244 pounds of methane every year. So each cow produces 244 pounds of methane. And again, methane is that extremely powerful greenhouse gas, 86 times more powerful than CO2. Next slide. Well, animal manure generates greenhouse gases also, including nitrous oxide. When manure decays, it releases into the atmosphere nitrous oxide, which is a very powerful greenhouse gas. Once this nitrous oxide is in the atmosphere, it has a lifetime of 144 years, and it's 300 times more powerful in terms of warming than carbon dioxide. So we mentioned that methane is 86 times more powerful than CO2. Nitrous oxide is 300 times more powerful. The fertilizers, so it's produced as a result of having manure around, but the fertilizers used to produce livestock are another and a less direct source of nitrous oxide that's attributed to livestock production. That fertilizer is used to grow the plants, which then are fed to the cows. In all, raising livestock makes up about 65% of all nitrous oxide emissions globally. It's noteworthy that manure also releases methane and carbon dioxide, in addition to releasing this very powerful nitrous oxide gas. Next slide. Okay, this slide shows the fossil fuel use versus protein produced. And what I want you to do is focus on the right column there of this slide. This table shows the relationship between the amount of fossil fuel used and the amount of protein generated for various foods. And lamb and beef are at the top two categories here in terms of fossil fuel intensity. The ratio is measured in kilocalories of energy obtained. So for lamb, it takes 57 energy equivalents to make 1 kilocalorie or energy equivalent of lamb meat. And for beef, it's 40 to 1. Look at how high that is compared to chickens, which is noted as broilers on the bottom. This is 4 to 1 compared to lamb 57 to 1 or beef 40 to 1. So chicken is much less intensive in terms of the energy needed to produce it. By eating less red meat, we can make food choices that are really much lighter in terms of their impact on the earth. It's interesting to note, although it's not shown on this slide, that the energy intensity for producing sugar and fat is fairly low. So that if you're eating a donut and someone comments that it's not good for your health, you can always just tell them that you're sacrificing yourself for the good of the planet. Okay, next slide. Loss of tree cover. Trees are part of a healthy climate, and we can't get away without trees. They offer shade and cool temperatures. They absorb CO2 from the air. They store carbon. They prevent soil degradation and erosion. When trees are removed for farming or for grazing, we lose that important carbon dioxide sink, so to speak. We lose that sink because we both lose the CO2 absorbing ability of living trees, but also because a tree, when it's cut down and it dies, gives up the carbon that it's been storing for many years and lets it go back into the atmosphere. Also, there's more direct sunlight. When there are no trees, there's more direct sunlight hitting the ground. It makes things warmer. It increases soil temperatures and contributes to soil degradation and erosion. We also lose the flood control that trees provide. And as we've already seen, flooding contributes to erosion and water contamination. Next slide. Other climate impacts on agriculture take place really away from the farm. Food produced on factory farms is transported an average of 1,500 miles. It requires gasoline to drive the truck, extra fossil fuel to refrigerate the truck along the way so the food doesn't spoil. The packing process also is fairly fossil fuel intensive because plastics, which are normally used for packing, are produced with petroleum products. And the packing, once it's used, also eats up more fossil fuel when it's disposed of, whether it's taken to a dump or hopefully would be recycled. But either way, it uses additional energy. Next slide. The good news is that you can make choices that are good for the earth, good for you, and that actually taste very good. You don't need to suffer to help our planet. Next slide. Making climate healthy choices. As I've noted, your food choices can contribute significantly to the well-being of the earth. For example, you can eat 20 servings of vegetables in order to get the equivalent greenhouse gas emissions of just one serving of beef. So give up one serving of beef and you got 20 servings of vegetables before you meet that same number of greenhouse gases. If you choose to go vegetarian, you can reduce your carbon footprint by 1.4 tons of carbon dioxide per year. And even small reductions in the consumption of red meat can have a major impact because of the energy intensity and carbon equivalent intensity of red meat. Next slide. There is a very compelling health case for eating less red meat as well. Studies have found that eating red meat increases your risk of a variety of health conditions: obesity, high blood pressure, diabetes, heart disease, cancer. And this is important. According to a Harvard study, 30% of all cancers around the world are attributed to diet, and this red meat is something that increases the risk of cancer. So there's a very good case for a health case for us individually for not eating red meat. Next slide. There's also a very compelling health case for eating less dairy. Milk, like beef, has many problems related to the climate. It comes with the issues of methane production, nitrous oxide gases production, high energy intensity per pound of milk produced, and the pollution related to runoff of manure, runoff from manure stores. And we don't really need dairy. We don't really need milk in order to maintain our health or have our kids grow up big and strong. And we don't need it to avoid health conditions like osteoporosis. Milk is just one of many sources of protein and calcium. Dark leafy green vegetables and legumes can deliver as much calcium as meat can. And as well, it has a healthy amount of vitamin K, which is also responsible for aiding calcium regulation and the bone formation. So that's an added benefit of these green leafy vegetables and other forms of other methods of getting calcium rather than through our dairy. And there are other reasons to other health reasons to reduce dairy consumption. Whole milk, butter, and cheese, like red meat, contains large amounts of saturated fat, which can increase HDL cholesterol. This is the bad cholesterol. And high bad cholesterol levels, high HDL levels, are linked to atherosclerosis around the body, in the heart, and many other areas. In addition, higher intakes of dairy products have been linked to higher risk of prostate cancer and ovarian cancer. Dairy products, milk particularly, can contain pesticides, growth hormones, growth factors, antibiotics, PCBs, dioxins. The bottom line is that milk really isn't that good for you, and there's no absolute need to have any of it. Okay, next slide. Okay, well, let's look at some solutions we have here. The next slide. The most important thing you can do is to reduce your consumption of red meat, especially beef and lamb. Poultry is a relatively low impact meat in terms of the climate, and it provides you with plenty of protein, an equal amount as red meat. You can also get the protein you need from grains, beans, seeds, soy products, fish, and other seafood. Having a meatless Monday or meatless Wednesday or meatless all weekdays is a good idea and a way to allow you to gradually explore alternative dishes and to move away from eating red meat or meat in general. One very good approach is to eating less meat is to commit to being a vegetarian or a vegan up to dinner each day. You're not denying yourself completely, but you're using the first part of your day to explore different kinds of foods and to realize that you can get along very well without having meat as part of your diet. It's a more gradual approach that's easier to start and easier to stick to. Next slide. Okay, well, this just shows the healthy food plate. This is from Harvard Public Health School, and it's just one example of a their idea of what a healthy plate would look like in terms of proportion, you can see that most of it's vegetables and fruit and whole grains, and not so much protein. And it says healthy protein, so it says choose fish, poultry, beans, and nuts. Limit red meat and cheese. Avoid bacon, cold cuts, and other processed meat. And I should mention also that of all the red meats, processed red meat, things like bacon, bologna, other things that are significantly processed are much more connected with health conditions like cancer than other meats. So those are particularly bad for you, if not for the world. Okay, next slide. Okay, so the bottom line is that your dietary choices are extremely important for the health of our planet and literally for the future of our species. The most important takeaway is that red meat is the biggest offender in terms of our food contributing to climate change. Small changes in your red meat consumption can have a huge impact on your carbon footprint. You know, as healthcare providers and those affiliated with the healthcare or public health sector, we all have a moral obligation to do all we can to protect the health of our planet and the health of all those on it. I encourage you to seriously consider your consumption of red meat and to cut it out whenever possible. The bottom line is it's not good for you and it's not good for the world. So think seriously about that and also about other issues which we discuss here. And a change in your diet can make a huge difference. I encourage you all to modify your diet whenever possible. Thank you.
Great. Thank you so much, Dr. Martin. This is Kathy Attar again. I wanted to thank you for that wonderful presentation. And now we're going to take a few questions. So the first question is related to lamb, and they're wondering why lamb has such a high fossil fuel impact.
I think it just has to do with the growth of the animal, how it grows, and how much meat is available for the amount of calories consumed.
Okay.
You know, it's a variety of things. I have to go into the details of you know, what that calculation, but it's basically has something to do with the production process. Just like chicken is extremely lower than red meat. This has to do with the production process, how quickly chickens grow versus how quickly cows or lambs grow, and how much food it takes to get them to grow.
There was a follow-up question related to eggs and the reason why on that chart, why were eggs more energy intensive than the broilers or chicken meat?
Again, I have to go back and look at the basic data, but let me see. This is eggs. Yeah, that's a good question. Has to do with something about the how quickly you can get chickens to grow and how quickly you can get eggs produced and that sort of thing. How much energy it takes to produce an egg versus how much it takes to have a chicken grow and produce muscle. So I can't give an exact answer to that, but we give a reference on that slide, so one can go back and look at the details.
Great. And another question, they wanted to get your thoughts on kind of more of a global question about what do you think is preventing society from eating less red meat?
Primarily habit. It's a matter of habit. We have great substitutes. We have substitutes that taste equally as good. I know I'm sure people would argue with me on that, but I think it has to do with the habit of what their tastes have gotten used to. And you talk to people who have not eaten red meat for years, and they wouldn't want any. You know, they don't crave it, they don't desire it. So it's really habit. There's no reason why we need to have red meat. We can get everything we need from other sources, other easily available sources. So there's no reason to consume red meat, really. It's not good for you. It's not good for the world. Why would you do it?
And then we had a question related to how health professionals, for example, doctors, how do you think they can help spread this message, your message essentially? Do you have any suggestions around outreach?
Yes. I see patients myself at San Francisco, at Zuckerberg General Hospital in San Francisco, and I talk to my patients. And one of the things I do is I talk to them about if they're trying to diet or if their cholesterol's high. I'll tell them, cut out the red meat. It's not that good for you. It's, there are very good substitutes. If you want protein from animals, eat chicken, eat fish. Red meat is not that good for you. It raises your cholesterol level. It's associated with a variety of health conditions. And I'm surprised. So many times I tell patients things, they just totally don't pay attention to them. I ask them to lose weight, stop smoking, do other things. They don't, you find the next visit they haven't done it, and you get a little frustrated. But surprisingly with this, when I talk to them, when they come back, they say, yeah, I've cut down on the red meat. They haven't given it up, but they've cut down. It's made a difference. And I think because the doctor has told them, hey, reduce it. It's not that good for you. They take that to heart. It's encouraging on that perspective for me.
Great. There was also a question about if you know anything about what organizations are educating and advocating within the medical community about diet change.
Well, there are. It's hard to look. You can look pretty. You don't have to look too far to get recommendations from almost all the health authorities on eating less red meat and reducing our consumption of red meat. But there are a variety of organizations that promote healthy diet, and I've started one myself called Physicians Against Red Meat that has a website called PHARM, PHARM.org. But red meat is a danger to the world, and we need to be cautious and careful about how much of it we use, because it's again not good for us and not good for the world.
And then we have a final question about kind of local food production and whether or not CSAs and local organic farms, whether or not they'll be able to make a dent in the, our kind of standard petro-agricultural complex. Like, do you have any thoughts about that, about the local kind of food movement?
Well, I'm very much in favor of the local food movement. I'm very much in favor of organic movement, but we can't feed the whole world through local farms, and at this point, we can't feed the whole world overnight by changing to organic farms and to local farms. We need a very intensive food production system to have enough food for the world, to feed the world. Now, if we eat less red meat that takes less grain or less protein, even less animal products that takes less grain to make red meat, then we'll have more fields to plant other things, and it's a much more natural and appropriate approach to providing food for everyone. But it's going to be a slow process because we can't change overnight to having everything organic and everything grown locally, and then still hope to feed the world.
Great. And actually, there was one last question. It was related to whether or not, if you know of any particular book that you can recommend to find out more about how food choices impact climate and climate change.
Well, one very good book that I've looked at is called Veganist. And Veganist talks about 10 reasons why one would want to be a vegan. And I read this book, and a few years ago, And I looked at the 10 reasons that they gave, and I, being a very logical person and scientific person, I said, well, after I finished, I said, well, now which one of these could I disagree with? Which of these 10 reasons could I disagree with? And the answer was, well, none. They all were pretty compelling. So that's an interesting book to read because it provides a very good case for reducing your consumption of certainly red meat, but also other things, other meat products as well. That's one I could highly recommend.
Great, thank you. Thank you so much, Dr. Martin. There was also a couple of questions about PSR's own policies around food and eating, and I just have to say, I think it depends on the different chapters. I know different chapters, when they put on events, they often have vegetarian and vegan options available for folks, whether it be at a conference or a meeting. But I'm unaware of any particular organizational policy around food. But we do, like I said, when we do have meetings and conferences, we definitely offer vegetarian and vegan options for our participants and members. And I know, as Dr. Martin is very active in the San Francisco PSR chapter, they are also very active around healthy eating and changing healthy policies around healthy foods, targeting hospitals, clinics, and other health systems. I know that they've done quite a bit of wonderful work around that as well. So,
yeah, one of the things we're trying to do at UCSF is to get the institution to not serve red meat at any of its institutionally sponsored functions.
Great.
Our approach on that is to say, well, if it's not good for the people who are attending, and it's not good for the world, and it contributes to greenhouse gases and climate change, why should the university be serving red meat at meals?
Yeah, definitely. I mean, I'm a strong advocate of trying to change institutional policies that then flow down to the individual behavior, right? I think that can be also a pretty good tactic as well. Okay, that's not seeing any other questions. I want to thank everyone for attending today's webinar, and I wanted to thank Dr. Martin for giving such a great presentation. And have a good afternoon, everyone else. Thank you.
Thank you.